Hello my dear children, welcome to my channel Sudhir Sir Chemistry Classes. This is my second video about chemical bonding because in my previous video I discussed about the introduction part and the types of the interaction. If the interaction takes place between the atoms called as the interatomic force of attraction, which is of following type: ionic bond, chemical bond, coordinate covalent bond. And second type of the interaction which takes place between the molecule called as a intermolecular force of attraction, and which is of five types: ion dipole interaction, dipole dipole interaction, dipole induced dipole interaction, induced dipole called as a London dispersion force, and fifth one is hydrogen bonding. So all the part I have discussed in my previous video. Now in today's video I am going to discuss about how to draw the structure of molecules. In this particular part, chemical bonding, how to draw structure of molecules. For writing the structure of or drawing the structure of any molecule, we should know about a first one, that is a Lewis dot structures, as well as we should know what is meant by a octet rule. Let us go with a Lewis dot structure. The first one, what is meant by this Lewis dot structure? For Lewis dot structure, we should know that particular atom of the element belongs to which group. Let us say hydrogen, it belongs to first group. So in its valence only it has only one electron. Same way lithium, in its valence only one electron. Sodium, in its valence only one electron. Go with the beryllium, it belongs to second group. In its valence how many 2 electrons are there? So can be written as a 2 dot. Boron, in its valence 3 electron, can be denoted as a 3 dot. Carbon, in its valence 4 electrons, so denoted with a 4 dot. Then nitrogen, in its valence how many? 5 electrons. So we should know 1, 2, 3, 4, 5, or it can be written as 1, 2, 3, 4 and 5. Same way, oxygen belongs to 6 group. In its valence shell it has only 6 electrons. So 1, 2, 3, 4, 5 and 6. So these are the oxygen. Same way, fluorine belongs to 7 group. So 1, 2, 3, 4, 5, 6, 7. So it is a Lewis dot concept or Lewis dot structure for any element. What is this dot indicate? That in this particular atom, in its valence shell, it has only one electron. So those who are having a 1 electron in the valence shell can be written as 1 dot. Those who are having a 2 electron in its valence shell can be denoted with a 2 dot. Those which is having a 3 electron in its valence shell can be denoted with a 3 dot, 4 dot and so on. It is about the Lewis dot structures. This is the first concept. We should know how to draw. Second one, what is in the octet rule? So I think, my dear children, did you understand this Lewis dot structure? How to draw? It is based on the number of valence electrons. Now second part is that octet rule. What is in the octet rule? That atom or the ions are getting the stability if it has the 8 electron in its valence shell. So second part we are going to see about the octet rule. Octet rule means for getting the stability, this atom or ion should have a maximum of 8 electrons in its valence shell. If it has 8 electrons in its valence shell, that particular atom or ion becomes stable. That means to acquire stability, either it will lose electron or it will gain electron. Let us have a simple example of sodium whose atomic number is 11. Configuration can be written as 2, 8, 1. First shell K, second shell L, last shell M, last shell called as the valence shell. Check it here in the sodium atom. In its valence shell only it has 1 electron. So what is that? It should have a 8 electron in its valence shell. For getting a 8, it cannot gain 7, but instead of that it will lose 1, and by losing only 1 electron it will get 1 positive charge. That means the configuration become 2, 8. This is a K and this is a valence shell having 8 electron, and it attain what? Stability by having what? Octet configuration. So what is in the octet configuration? Having a 8 electron in its valence shell called as the octet configuration. How the sodium atom is acquiring the octet configuration? By losing 1 electron. So atom bearing a positive charge are called as what? Cations. It is the first one. Second example of chlorine, atomic number 17. Configuration is 2, 8, 7. First shell K, second shell L, valence shell M. Check it here in the valence shell. How many electrons are there? 7. So it will also get the stability by gaining 1 electron, and now configuration becomes 2, 8, 8. That is K, L and M. Check it here in the valence shell, 8 electron is there. So it will attain its octet configuration by gaining 1 electron, and atom when it gains 1 electron it will get one negative charge. Atom having a negative charge are called as a what? Anion. So it is a octet rule. But in this octet rule some exceptions are there that we should remember, and these exceptions can be seen only for these two elements. Hydrogen and helium are getting the stability by having a 2 electron in its valence shell, and that will be called as a what? Duplet configuration. So these hydrogen helium are getting the stability by having a duplet configuration, means it should have only 2 electrons in its valence shell for getting the stability. Other than that, remaining all elements are having a octet electronic configuration, having a 8 electron in its valence shell. So my dear children, to draw the structure of molecule we should know about the Lewis-Dot structure and octet rule. Lewis-Dot structure means that particular atom of the element belongs to which group. Based on that, it present on which group, we are able to identify how many number of valence electron present with that particular atom, and based on that number of valence electron in the particular atom we can give the dot. If the atom is having only 1 electron in the valence shell, so symbol of the element having only 1 dot, it is a way. And second one, octet rule, having a 8 electron in the valence shell. Now let us check the examples based on these two concepts, how we are able to draw the structure of molecule. Now listen here. In this particular part, for drawing the structure of these molecules, how to use the two concepts. Let us say example number 1. I want to discuss about the hydrogen molecule. We know hydrogen belongs to first group, it having 1 electron in the valence shell. Hydrogen symbol H belongs to 1 electron in the valence shell according to Lewis-Dot structure. Then octet rule. Already I told you exceptional case can be seen with the hydrogen and helium because they are getting the stability by having only 2 electrons. So these hydrogen will take this electron from the hydrogen and it will attain the stability. So this hydrogen will have 2 electrons. This hydrogen also taking this electron from here and it will also attain the stability by having a duplet configuration. So both the hydrogen atom are sharing their electrons, and by sharing it will form the bond. And please remember my dear children, the bond which is formed by sharing of electron, are called as a covalent bond. So it is the first type we have seen about the covalent bond. Here this hydrogen atom is having a duplet configuration. Check it here, this hydrogen is having how many? 2 electrons. This hydrogen also its own and other electron form here, duplet, and they attain the stability. Second example, we will check it with the Cl2 molecule. Let us say chlorine, it belongs to 17 group, that means 7th group, having 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7. Same way, other chlorine, 1, 2, 3, 4, 5, 6, 7. Now this chlorine will take this electron to complete its octet. Now check it here, with this chlorine how many electrons are there? 2, 4, 6 plus 2, 8. For this chlorine, 2, 4, 6, it will take this electron and it will complete its octet. You can check it here, chlorine are sharing its electrons to complete its octet, and we know that the bond which is formed by sharing of electrons are called as a covalent bond. So here each chlorine atom is acquiring the octet configuration. So what is the concept we use? First we have drawn the Lewis-Dot structure and then we have checked it with the octet rule, and this is the structure of the molecule. Is it clear? But one more simple example I want to discuss with you, and that example is HCl molecule. Let us say I want to write this part here. The third example which one I want to explain you, it is about H and Cl. HCl. Hydrogen belongs to first group, 1 electron. Chlorine belongs to 7th group, so it should have a 7 dot according to Lewis. Chlorine is getting the stability by having the octet, check it here. Hydrogen is getting the stability by having a duplet, and this is a bond formed by sharing of electron, the bond called as a covalent bond. Now my dear children, check it here. In between H and H the bond is a covalent. In between Cl and Cl the bond is a covalent. In between H and Cl the bond is a covalent. I will say this bond is called as a covalent bond, but this is called as a non-polar covalent bond. Here non-polar covalent bond, but here it is called as a polar covalent bond. Means we are going to learn here covalent bond. Again it is of two types. The first one will be called as a polar covalent bond, second one will be called as a non-polar covalent bond. The very short trick method about that covalent bond I want to discuss with you. Please remember here. Covalent bond, that means the bond present between two non-metals. In between two non-metals, the bond is called as a what? Covalent bond. If both the non-metals are same, then it is called as a non-polar covalent bond. And if both the non-metals are different, then it is called as a polar covalent bond. Let us go with a deep concept over it. In between hydrogen and hydrogen, we don't have any electronegativity difference, because hydrogen electronegativity value is 2.1, here also 2.1. The difference is 0. So no electronegativity difference. That means no does not form any polarity over the bond. The molecule become a non-polar. Same case for chlorine. But here H, electronegativity value 2.1. Chlorine, electronegativity value 3. That means it has an electronegativity difference. That means here the bond movement will move from hydrogen to chlorine. So chlorine will get a partial negative, hydrogen will get a partial positive. First of all, we have seen that the bond is a covalent. But in this bond, it developed a polarity, positive and negative. So formation of a polarity over the covalent bond called as a polar covalent bond. And this polar covalent bond can be formed between two different non-metals because they have electronegativity difference. So this is about the complete explanation about the structure of the molecules, and that one we did based on the Lewis dot structure as well as the octet rule. Now we'll go with some more examples here. Now check it here, some more examples. That examples mostly they used to ask in your IIT mains, even in the advanced, or sometimes they used to ask in the NEET exam also. So that part I want to discuss with you. And now listen here, the part which I am going to discuss is a very detailed and complete explanation, different part of this one. Here they used to give for a molecule called as a NO plus molecule. Actually it is a, we can say it is a radicals and all, because it is a particular molecule having a positive charge. At the same time, second example I want to write for you, that is a OH and negative, radical only. Here my doubt, or mostly children are having a doubt, sir, this positive charge present over where? Either it is over nitrogen or oxygen. So negative charge present over where? Either it is over hydrogen or it is over oxygen. So my dear children, I am going to tell you a very simple and very short trick method. Based on that we are able to do this kind of the question, because in exams, mostly NEET exam, they used to give the radicals and they used to ask what is the formal charge over that particular atom. So no need to buy the formulas for the formal charge and all. So I will give them a small concept. Please listen here. Let us go with this example, NO plus ion. We know this particular NO plus ion, it is a radical or it is a ligand which is used in the brown ring complex. And my dear children, a very simple question they used to ask, in the brown ring complex central metal atom will have a which charge? Either +1, +2 or +3. We know that in brown ring complex central metal atom is Fe, and Fe whose according to that one they give the option +1, +2, +3, and we know Fe will exist only in the form of +2 and +3, but in the brown ring complex Fe oxidation number not a +2, not a +3, but it become a what? +1. Now instead of that I am going to draw the structure of this one. First of all, we should know how many valence electrons are present over the nitrogen. So we know that 5. Oxygen, how many valence electrons are there? 6. And positive charge, if it is there, 6 plus 5, 11. Positive charge it will be there, means it loses 1 electron, so it becomes a 10. So I should write the first point. Total number of valence electron present over the NO plus is equal to 10. Then draw the structure. Let us say N bonded with a O, and we are having attached with this one. Now out of 10 we made one bond, but a one bond is equal to 2 electron, means out of 10 we utilized 2 electron, remaining is how many? 8 electrons are there. 8 electron which is left with us, that 8 electron we have to utilize to complete the octet of the atom, which is become more electronegative. And my dear children, everybody know that among the nitrogen and oxygen, oxygen is more electronegative. So all these 8 electron, 2 plus 2, 4 plus 2, 6. Out of it we have given 6 electron to the oxygen, and oxygen completed its octet. 2, 4, 6 plus 2, 8. Now out of 8 we have given 6 electrons to the remaining 2 electrons are there. Give it for the nitrogen. By giving the nitrogen, nitrogen does not complete its octet. So we will draw the another structure. Nitrogen bonded with the oxygen. Here it is. This one of the lone pair present over the oxygen, that will be utilized for making a bond. Remaining to keep it here. Now again check the stability of oxygen. 2, 4 plus 2, 6 plus 2, 8. Oxygen stable. Nitrogen 2 plus 2 4 plus 2 6, still it is unstable. Now we will utilize this third one to complete the octet of nitrogen. So first two bond as it is, and this third lone pair over the oxygen will make a third bond and oxygen. This is lone pair, and instead of writing here I will write the lone pair over here. Oxygen 2 4 6 8 completed. Nitrogen 2 4 6 plus 2 8 completed. So all the atom present in the given ion or given molecule was completed its octet. Now this charge present over which atom called as a formal charge. But a formal charge, whatever the formula it was given in NCERT, instead of that a very simple method I will tell you. How many electrons are present in the valence shell of the oxygen? 6. And now 1 2 3 4 5. 6 minus 5, that is equal to 1. Which one? Plus 1. So oxygen will have a 1 positive charge. Formal charge of oxygen is plus 1. Nitrogen, number of electrons present in the valence shell of nitrogen, how many? 5. And here how many? 1 2 3 4 5. 5 minus 5 equal to 0. No formal charge. Now we can say in this NO plus ion positive charge over where? Over the oxygen. And this one nitrogen does not carry any charge. Same thing we will try it for the OH minus ion. Let us say total number of valence electron present over the this one. Oxygen how many? 6. Hydrogen how many? 1. Total how many? 7. 1 negative means gain of total is equal to 8. Now oxygen bonded with hydrogen. Out of 8 we utilize how many? 2 electrons for making a 1 bond. Remaining electrons left with how many? 6. 1 2 3 4 5 6. Or total 6 plus 2 8, 8 electron we utilize, and oxygen completed is octet as well as hydrogen also completed is octet by having a duplet configuration. Now check the formal charge. How many electrons are present over the valence shell of oxygen? 6. But here how many? 2 4 6 plus 1 7. Oxygen will have a 1 negative charge. Hydrogen in the valence shell only 1 electron and at present also 1, total equal to 0. So what is the formal charge of oxygen on the OH minus ion? On the OH, there is oxygen bearing negative charge, hydrogen does not bear any charge. It is a way to write the structures of any molecule. Based on that, we are able to draw the structures. Okay, these are the complete thing that I want to discuss about the structure of molecules. After this one, my next topic, next video, I want to discuss about types of chemical bonding. That is ionic bond, covalent bond, and the coordinate bond. Thank you, my dear children. If you like my videos, please you can write in the comments, and if there any topic if you require other than that, please inform me. I will try to upload that video. Thank you very much.